Have you thought about making a podcast of your own, but you're not sure where to begin or what the process looks like? Well, I use Anchor because it is the easiest way to make a podcast. They give you everything you need in one place for free, which you can use right from your phone or computer. Their creation tools allow you to record and edit your podcast so it sounds great. They'll distribute your podcast for you so it can be heard everywhere: Spotify, Apple Podcasts, Google Podcasts, and many more. And you can easily make money from your podcast with no minimum listenership. So download the Anchor app or go to anchor.fm to get started.
Hello and welcome to Leaflet, Educational Research Made Approachable. Today we are going to be discussing an editorial special topic. That's right, we're not reading one research paper. We are discussing neuroscience, learning, and educational practice, its challenges, promises, and applications. This is a special topic from the January to March 2018 edition of AERA Open, Volume 4, Number 1, pages 1 through 4. So they basically did my job for me. They introduced a slew of related research papers, all related to neuroscience and educational practice and how the two can come together and kind of feed off of one another and be more involved with each other than they have been in the past and currently are at the present. But we're going to break it down even more. We're going to talk about the key elements of each paper. We're going to make this as understandable as possible. This is super exciting stuff, guys. So listen up. This paper serves as an advocacy for more collaboration between educational research and neuroscientific research, with special interest in how neuroscientific methods can serve educational practices as well or better than behavioral approaches to pedagogy. Through summary and review of 5 educational research studies related to neuroscience, Jaeggi and Shah claim that such research and implementation of methods based upon it demonstrate potential to develop deeper models of learning and cognitive growth. Their 3 stated goals for a higher focus on neuroscience and education are to advance understanding of the underlying basis of learning deficits, to assess whether educational strategies have their intended impact, and to provide earlier identification of potential learning difficulties than behavioral assessment allows. The key question must be, what puts neuroscientific research in educational context above and beyond behavioral work? The implied question underlying the approaches and findings of each study summarized is, how can neuroscientific and behavioral research and assessment add to one another? This implied question is not stated because behavioral assessment is already the assumed default method and therefore requires little advocacy for implementation. The first study cited argues for the convergence of evidence from neuroscience, cognitive psychology, and education in creating and critiquing models of reading development. Some suggestions for the implementation of neuroscientific methods include neuroimaging techniques and eye tracking when studying reading development. The second paper summarized studies executive functions and visuospatial skills in relation to their impact on mathematics learning. Guided by the hypothesis that the study of atypical cognitive development could enlighten that of math learning development, researchers observed the distinct cognitive profiles of students with ASD and Williams syndrome. The research suggests that neuroscientific research can adequately study how these deficits affect math learning and can reveal potential difficulties in mathematical development before behavioral evidence even begins to surface. The third study uses evidence of shared neural networks to guide interventions in math development. Because experience playing action video games has been shown to increase foundational cognitive abilities, primarily attention control, researchers seek to understand whether such experience can improve one's mathematical abilities. While the researchers conclude that action video games are, quote, not detrimental, unquote, to mathematical abilities, the only evidence in favor of their hypothesis is increased computational speed and success. More abstract or complex areas of mathematical development did not improve as a result of the experience. The fourth study is designed to assess the neurological impact of small-scale interventions in collaboration with behavioral assessment. More specifically, researchers seek to understand how task instructions that emphasize mastery and/or performance goals influence neural response to negative feedback, student engagement, and academic improvement over time. While differential effects were observed by the neuroscientific assessments, these were not present in behavioral outcomes. The magnitude of neural signatures were shown to be highly influenced by the personal goals of each student. The implications for educational practice is that a focus on mastery and performance goals only serves cognitive development with any significance when the goals are aligned with the personal goals of the student. Otherwise, such approaches may even be harmful, let alone insignificant. The fifth study briefly reviews the impact of stress exposure on biological systems and how this exposure can negatively impact cognitive performance. Stress exposure at home can affect how students respond to stressful situations in the classroom, such as high-stakes testing. Researchers propose efforts to reduce student stress by means of mindfulness interventions and an increased focus on sleep quality and quantity for students. I tell you what, I need an increased focus on sleep quality and quantity in my life. Together, these studies demonstrate that neuroscience can help develop models of reading development and math learning. Furthermore, the final study suggests that neuroscientific research might be the key to a more base-level understanding of student stress and its impact on development. Neuroscientific research does seem to add value above, but only when in conjunction with, behavioral data. For this reason, it is suggested that the relationship between neuroscientific and educational research become more reciprocal. Of course, because of the allure of neuroscience, an ethical dichotomy must be considered. While neuroscientific data in the context of educational research could further inform policy development and pedagogical practices, researchers could also misguide the public by implying that anything in brain-based research is superior to that in other fields because of its clinical, analytical approach, let alone its novelty. This has been episode 9? Oh my goodness, guys. This has been episode 9 of Leaflet Educational Research Made Approachable. As always, if you'd like to read the paper or the transcript, both will be in the description below or wherever the heck that thing is. I will see you guys next week. What are your thoughts on neuroscience as opposed to and in conjunction with behavioral data? Where does neuroscience fit in educational policy development, in curriculum development, in pedagogical approach, in educational research in general? Where does it fit? Does it have a place? What is it? Let's talk about it. Let's have a discussion. Let's learn from one another. Let's keep learning. I will see you guys next week. Peace.